The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending today's webinar, External Corrosion Direct Assessment, the how-tos, do's, and don'ts for a proper ECDA execution. It's great to have you back here with us this morning. My name is Marissa Davis, and I'll be facilitating. As always, we'll be taking questions at the end of the presentation today, so if you have one, you can go ahead and ask it via the question function, and I will be happy to answer it for you. All right, the host of today's webinar, G2 Integrated Solutions, provides responsive support and a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, technology solutions that address asset performance through its life cycle. For more details on our services, please visit our website. And now I'll introduce you to our presenter, Al Giordano. Al joined our regulatory compliance team earlier this year as a senior regulatory consultant. He's a licensed professional engineer with several years of experience in the energy industry and a focus on DOT regulatory compliance, regulatory audits, project management, and integrity management. So Al, without further ado, go ahead.
Thank you, Marissa. Good morning, everyone. Thanks for joining us this morning on the webinar. Again, like Marissa said, today we're going to be discussing external corrosion direct assessments, do's, don'ts, how-tos, and some high points and guidance for completing an ECDA project. So pipeline assessments have always been a fairly significant part of operating a pipeline. Recently, inline inspection tools have become the de facto method when available to perform an assessment on a pipeline. However, ILIs are not always the most feasible assessment method due to cost concerns. You may have a smaller operator with low mileage, sections of unpickable lines with multiple diameter changes, or short runs of lines where ILI tools just aren't feasible or cost effective to get in. External corrosion direct assessments, or ECDAs, they can provide a great set of information on the external corrosion of a pipeline, particularly if the operator has identified that threat as a high probability on that segment of line. We're going to go through each of the 4 phases of ECDA, identify some do's and don'ts, and some key points when you're executing an ECDA project. So, a true ECDA project has 4 phases. It has pre-assessment, indirect inspection, direct examination, and a post-assessment phase. Each phase is designed to work with the previous phase in sequential order. So data from the pre-assessment phase will eventually tie into all 3 of the following phases. Your indirect inspection phase will then add another layer on top of that data to tie into the direct examination and the post-assessment. Completing these in order will impact how decisions are made and the data that's obtained during the project. When it's completed, the ECDA project will be able to integrate data from multiple field examinations, pipe surface evaluations, operating history, and historical records to build a comprehensive assessment on the external corrosion and the external condition of the pipeline itself. So in regulation, the NACE ECDA standard, SPO 502, is one of the few standards that are directly incorporated by reference for corrosion control. Part 192, it's 49 CFR 192.7 H1, and 195, it's 49 CFR 195.3 G2. Those are the incorporated by reference sites if anybody's interested. Since the standard is directly incorporated, operators should read and heed the requirements and be sure to follow the steps properly. You want to make sure you're documenting everything fully in order to remain in compliance. Historically, lack of documentation, incomplete procedures have been one of the biggest issues for operators in regards to ECDA work. Either not doing what you're supposed to be doing, not having the procedures to execute the work properly, or not documenting it. Again, not maintaining proper records of the data that's being collected. And so we're going to discuss those. All right, so ECDA phase 1, pre-assessment. So the pre-assessment phase of the ECDA does primarily consist of data gathering. It collects historic and current data to determine whether an ECDA is feasible. It'll help define ECDA regions, which we'll talk about in a little bit. And it'll also allow the operator to select tools for use during the indirect inspection phase. Data collection will revolve mostly around construction records, operating and maintenance histories, alignment sheets, corrosion survey records, prior integrity assessments, and other operating and maintenance records that are relevant. Data gathering should be broad enough to consider everything that's pertinent, ensure that it's all evaluated properly, and it should provide a justification for determining the feasibility of the project. When you're collecting data, the data should always be considered based on the level of need to determine feasibility. Specific data records, such as previous CP surveys, for instance, should be classified as either a required or a mandatory document to have when determining what your pre-assessment phase, when you're determining the feasibility during the pre-assessment phase. Other data, such as manufacturing year or seam type, may not be a mandatory requirement, but it should be at least considered during the pre-assessment phase. And again, this is all up to the operator to determine what's required, what's mandatory. NACE SP 502 provides a good oversight, a good overview of what they recommend as being required data, but it is up to each operator to determine what is considered to be required data to establish the feasibility of the ECDA project. And again, feasibility should be established based on the overall availability of the data, the overall applicability to actually be able to get field measurements, determination of conditions which allow the ECDA to be executed. There's no major areas of electrical shielding. There's no major areas where you have soil conditions that aren't suitable for electrical measurements. Cased crossings, right? If you have a pipeline that's half a mile long, but a third of it's a cased crossing under a highway, well, maybe an ECDA is not the best option for that particular segment of line. So once the data collection's been finished, operators should determine what tools to use based on those data collection results. Tools should always be chosen via data-driven selections. For example, newer pipe, maybe with an FBE coating and anticipated pinpoint holidays, maybe it's a newer line, or you're doing an ECDA on an HDD where you may have small holidays based on the, pulling the line back. You may be best served using a combination of a CIS or maybe an ACBG or a DCBG tool. Current mapping tools may be a good idea if data collection anticipates you've got straight current available. So that might be a good tool to use. NACE SPO 502 does require that you use at least 2 tools for all locations and regions. Tools selected should be complementary to each other in order to develop as complete a picture as possible. One area that operators can get some information from is Table 2 in NACE SP 0502. This provides a breakdown of tool selection based on certain conditions that you may encounter on the right-of-way. You can use this table as kind of your basis to determine what tools you want to use. It's a good idea to incorporate a table like this or develop a table like this to put into your procedures. So once operators have selected their tools, you should begin to determine region selection. As defined in SPO 502, NACE considers a region to be a section or sections of pipeline that have similar physical characteristics, corrosion histories and conditions, and use the same inspection tools. So region selection can be a commonly misunderstood or omitted portion of the pre-assessment phase. Operators may look at a pipeline and call the entire pipeline one region. This can be inappropriate unless you can demonstrate that all the characteristics across the entire segment of the line are common. If you have all in the same soil conditions with no other variables that have been introduced, it's got the same coating type throughout the entire segment, you may be able to call that one region. However, if you have 15 miles of pipeline, you've got multiple road crossings with casings, you've got some sections that have FBE, you've got some sections that have coal tar coatings, you need to break those up into different regions. Additionally, if you have different soil conditions, maybe part of it's going through a swampy area or part of it's going through an area with more arid soil, it's good to break those up into different regions to help establish what tools you're going to use and then how you're going to take those readings. Regions don't have to be continuous. They can start and stop across the entire length of the inspected segment, but each region, again, should have similar characteristics. Failure to define regions appropriately would be a consideration for violation because the procedures are incorporated by reference in the regulations. So operators should make sure that they're following the steps properly. So this diagram is direct from NACE SPO 502. Kind of highlights where operators can encounter different types of environments along the pipeline and how those environments may impact the type of tools used. So you see in the first section there, it's got CIS and DCVG. They're calling that two regions there based on soil conditions, physical characteristics. Then there's a segment using cure and attenuation tools. The previous diagram in NACE SP 0502 identified the section with current attenuation tools as a paved location. So CIS and DCVG would be ineffective across that particular segment. But you note that on the other side of the current attenuation, you've got another segment or another region. They're calling region 1 for the ECDA. Again, that region may have the identical characteristics to the first region that was established. So you can continue to call that region 1, use the same tools, and continue on. Again, documentation of region selection is critical in that the data collection, soil characteristics, and previous history dictate the decision to break down the segment into different regions. Additionally, if you have features like cased crossings, casings do require their own separate region due to the inability for the tools to provide the data across those particular segments of line. So make sure you're taking casings and segmenting them out into their own region. So again, the most important thing to remember for the pre-assessment phase is proper documentation. Proper documentation will show that the operator has diligently followed the steps of the process, and that validates compliance with the procedures. Other considerations during your pre-assessment. For first-time ECDA projects, you may want to consider use of a third tool. You may want to broaden your data collection to include more data to help you better establish feasibility and better determine what tools to use, or you may want to make your regions a little bit more well-defined. Pre-assessment, and this goes for all phases, but the pre-assessment phase, it should generate a report which documents any decisions, all of your data collection, feasibility determination. If you have any missing data, that should be documented also. You should also make sure that your pre-assessment report defines what your regions are, either using a maps, station numbering, mileposts, some sort of means to determine where your regions start and stop. So that's the pre-assessment phase. Again, it's a lot of office work, a lot of document review, but a good pre-assessment phase will set you up for the rest of the project. So once you've completed your pre-assessment phase, it's been determined that an ECDA is feasible for this particular portion of line. It's been completed in its entirety, it's been accepted. You can move on to phase 2. So in this phase, field data is collected in accordance with the plan developed during your pre-assessment phase. Here again, as an operator, you want to make sure you have very well-defined procedures for the execution of the field survey. The goal of the field survey, again, is to locate and define the severity of any areas of corrosion or coating faults that may have occurred or are occurring. Again, the data collected in this phase is going to drive the rest of the project. So it's essential that you really get a good set of data from your field survey work. Make sure it's as complete as possible, it's as correct as possible, and as accurate as possible. For each inspection that you do, so for instance, if you have a CIS procedure, you have to have a procedure for that tool that's being used. That procedure should identify what your data and documentation requirements are. Again, I said a CIS procedure. So for example, a CIS procedure should identify what types of equipment are acceptable to be used, what type of interruption cycles you want to use when you're taking your on and off readings, spacing for your readings. You know, how far apart should your readings be? 5 feet, 2.5 feet? It all depends. What the acceptable criteria for your CP levels are. Are you using a -850 criteria? Again, it should be comprehensive. It should answer all of those questions. Another thing to note when you're starting your indirect inspection is that when you've defined region boundaries, they should be clearly marked for the folks that are doing the work out in the field. It's a good idea to build a buffer area into that region to make sure that you're not stopping short of collecting data or switching tools too soon before you move into a separate region. Again, you could use the same tool across multiple regions. It just depends on how you develop your plan. Again, if you're doing this for the first time ECDAs, you should consider when it's appropriate. If you gather data and it's not consistent, you may want to consider repeating the indirect inspection for that particular segment of line in order to validate what's going on there. And then finally, third-party contractors. A lot of operators tend to use third-party contractors for this type of work. They've got the specialty knowledge, they've got the expertise, they've got the experience in doing these type of surveys, this type of work. So the general rule is third-party contractors should always be following what the operator's procedures are. An operator should have a set of procedures. Smaller operators who may not have the resources to develop these procedures or rely on a third party, those operators should be accepting the third party contractors' documents, their procedures as part of their project. So they should be reviewing their procedures and making sure that the third party, the person who's doing the work, that those procedures are as complete as possible. And then also don't forget about OQ records. These are considered covered tasks, so make sure you're getting OQ records from your third party contractor using them. So once you collect your data, you've done all your field work. You should correlate the data. You should gather it all together, lump it together, and overlay it to align it for comparison with consideration for spatial errors. Because you're doing data evaluation on the information that you've gathered during the field inspections, this is going to drive your decisions as to where you're going to perform your direct examinations, where you believe corrosion may be imminent. This data and decision making should be fully documented again to validate where you're going to dig. When you're overlaying your data, if you're reviewing it and you indicate maybe perhaps you have a severe anomaly on one tool and you have no confirmation from any other tool being used, again, it may preempt you to go back and resurvey that section to confirm it. It may be just that there is a severe anomaly there that maybe an ACVG is picking up, but your CIS isn't noting anything. It's possible. But you want to make sure you have documentation to validate that. Data overlay is a great way to confirm results. You can minimize spatial errors doing that way. You can validate readings from different tools if you've got, and I'll show a picture of this on the next slide, but if you've got 3 tools and they all have an indication and it aligns correctly, it's a solid foundation for justifying a dig location there. Indications, you should align them as close as you can utilizing GPS. Again, if you don't correlate it, you've got to remediate it. One of the other actions you're going to do is you're going to classify your data. You're going to classify it based on the severity of the anomaly. So you should have a set of classification criteria in your procedures to determine how bad the indication or the anomaly is. It should be, SPO 502 defines them as severe, minor, or moderate. And then as an operator, you define what you consider to be severe, moderate, or minor. And SPO 502 provides some justification for that as well. So here's a quick graph of a ECDA project that we completed. You can see that right about 13 plus 75-ish, there's a dip in your CIS readings, your on and off, which is your top section of the graph here. There's a significantly high ACVG reading indicated by that little short red bar there, and then you're losing current on your PCM. So what that's telling us is that there's something there that's causing this to happen. And this is just an example of being able to justify each of the tools, right? Your one tool is justifying the results from another tool, which allows you to make better decisions. Again, finally, with the indirect inspection, the documentation is key. Your indirect inspection report should always document as much as possible, including dates, times, and whether that may have an impact on the data that's being gathered. It should again confirm your region identification, provide for your inspection results and data alignment. You should include references to the procedures that are used for each of the tools, give you a description of the classification and the prioritization if you want to include that in this report. Some operators do, some operators don't. And then always a graphical depiction of the data. It's generally the easiest way to look at the data for these type of projects. Spreadsheets can be thousands of lines, thousands of rows deep. So graphical depiction is generally the best way to look at data from an ECDA. All right, so phase 3. Operators now take that data that they gathered during their indirect inspection phase, and they prioritize their dig locations based on the severity to confirm what data was collected during phase 2, evaluate the most severe indications found, and then provide any sort of mitigation for those particular locations. You'll also do some evaluation of remaining strength. So the key parts here are the prioritization and the dig selection. So operators should, again, directly inspect the most severe indications per region based on guidance from SPO 502. And we'll also talk about how many digs per region are required. So prioritization should start before any excavations. Indications should be prioritized by either immediate, scheduled, or monitored. Immediate indications are likely to have ongoing corrosion, may have indications of prior corrosion, and then may be an immediate impact to pipeline safety. They should be ranked as severe by at least one or more tools. And then you may have a bunch of indications that may be ranked as moderate, but they're closely grouped together, which would turn them into a severe condition, which may again result in an immediate prioritization for a dig selection. Again, in the operator's procedure, you should always define how you prioritize digs, what your algorithm is. If you have a methodology for how to prioritize based on the severity of the anomaly, the location of the line, whether there's prior data to suggest there's corrosion present. And NACE does provide a good basis for this in SPO 502. But it is imperative that you define how you prioritize your digs. So, number of excavations, this is based on guidance from NACE again. You should, at a minimum, all your immediate indications should be excavated and inspected. If you don't have any immediate indications or the level of severity of a scheduled indication requires examination, it should be excavated. So if you don't have the immediate, if your algorithm doesn't define anything as an immediate, but you have a very severe location that may rank out as a scheduled, that one should go ahead and be examined. Again, if there's no immediates in a region, you should take the most severe of the scheduled indications and excavate that one. For first-time ECDA applications, an additional indication should be excavated for each region that contains a scheduled indication. If there's only one scheduled indication, the excavation should be performed at a monitored location. So for an ECDA, you're doing 2 digs. For a first-time ECDA, I apologize, you're doing 2 digs per region if there's no immediates. If there are immediates, the immediates get done first, obviously. But if you only have immediate or scheduled or monitored digs, then you're going to do the most severe of the scheduled or the most severe of the monitored. And again, if it's a first time, you're going to do the next most severe. Operators, you should define your timelines for excavation. Obviously, immediate indication should be excavated as quickly as possible, whether that's 4 months, 6 months, 8 months. It's up to you to define, but it should be as quickly as possible to go and excavate those and mitigate those. And then finally, effectiveness digs. This is one area where operators tend to either miss or don't fully complete it. How do you know if you're doing a good job? So you want to do 1 dig per region as an effectiveness dig in an area where there is no corrosion indicated. And what that does is it tells you whether your tools are accurate. It tells you if you're getting good data. And it also helps you in phase 4 if you need to reprioritize any indications. So as part of phase 4, which we'll talk about here in a minute, you're going to do an effectiveness review, and these effectiveness digs are a key part of making sure that the data that you're collecting, your procedures, your processes are all correct and effective. So phase 3, you're gathering your data firsthand. You're opening up the whole You're looking at the pipe, you're taking measurements. Phase 4 allows you to determine how successful your project was. It determines what mitigative efforts you're going to take in the future. It's going to allow you to reprioritize any indications based on actual data that you gather from your direct assessments. You're going to, again, calculate your remaining life of any indications that are still present. You're going to determine, as required, you got to come up with a reassessment interval. How much time is it going to be until we have to do this again? And then again, your overall effectiveness evaluation, which is an area where operators don't always finish up. They don't get to that point to determine how effective that their ECDA is. And again, being incorporated by reference, got to follow the procedure. That is a key part. So just to touch on these a little bit, mitigation, you should be identifying and performing any remediation activities on those those immediate locations, or developing a plan to tackle some of your other locations if they're not as severe, building that into your plan. Reprioritization. If you perform your direct examinations and it's uncovered that the corrosion or the damage is more severe than originally anticipated, you must reprioritize your indications. So if you've got immediate indications or you've got scheduled indications that, when uncovered, indicate a more severe level of corrosion occurring, the measurements and the data you're gathering from that should be applied to the other remaining indications to reprioritize those, as it may change, how you're going to attack those problems in the future. In general, again, if it's worse, you should reprioritize. If it's better than anticipated, you can also do that. If it's a first-time ECDA, you can't downgrade an indication, but if it's your second or third ECDA and you're gathering data and it shows that the corrosion's not as bad as originally thought, you can downgrade your indications. You can reprioritize those from a schedule to a monitor, which then pushes out the work a little bit. Basically justifying what you're, again, the data is justifying what you're doing, the decisions that you're making. If you don't find any indications, you don't have to do remaining life. If you do have indications that are remaining, whatever the scheduled indication or monitored indication that indicates the lowest predicted failure pressure, that's going to determine your remaining life on your pipeline. Reassessment intervals, that's going to be determined based on what your remaining life is, what your scheduled indications look like, and how much time you think you have until you have to mitigate those as well. Now, you are limited to reassessment intervals to 7 years. 49 CFR does define a 7-year interval. You have longer intervals, but you always have to do something every 7 years, whether it's a confirmatory direct assessment or some other method of assessment. You don't have to do a full assessment, but there are varying levels of actions that need to be taken at the 7-year mark. And again, the effectiveness assessment allows the operator to evaluate their indication criteria, the performance of their tools in the specific regions, and it gives data to apply to future assessments of, future applications of an ECDA. So if you're tracking, as an example, if you're tracking a number of reprioritizations and you find that over the last couple ECDAs that your reprioritization level is significantly high, you may want to evaluate your procedure to determine the reliability and the accuracy of your criteria for prioritization. So again, just some real quick do's and don'ts here. We talked about a lot of stuff today, a lot of different things going on. Just from a high level point of view, make sure all your procedures are complete, they're usable, they're understandable. You can have procedures that are directly out of code and nobody knows how to use them because it's just code language. So make sure that your procedures are as clear as possible. Make sure you can use them. They're actionable. Again, document everything. Document all your steps. Document all your decisions. Document all your findings. Make sure this is a very data-heavy process, but all that data ties into what decisions and what steps you're taking along the way, what decisions you're going to make in the future. I always like this quote, plan the work and work the plan. So pre-assessment, that's where you're planning out what you're going to do. If you plan it out correctly and then you work at how you planned it out, generally you're going to succeed. Always follow the process sequentially. Again, don't start a new phase until you finish the previous phase. There's some leeway there. You can kind of slide into the next phase, especially between your phase 2 and phase 3 if you're doing your classifications of your anomalies, and then you want to prioritize maybe as part of the end of phase 2, moving into phase 3. That's kind of a fluid area where you may, do a little bit of work in phase 3 before phase 2. But again, you're getting your data, you're doing your field work, you're classifying, you're prioritizing, and then you're digging. You're not digging before you do any of that work. So you're following the process. And then always allow the data to drive what your decision making is. Don't make decisions based on historical, hey, we've done this for 20 years. I know that it's bad here, or I know that it's bad there. Allow the data to push you in the direction that you need to go. Don't make generalized assumptions about data collection. A robust data collection in the pre-assessment phase is very, very valuable because it provides a lot of input at a lot of different parts during the process. Again, don't always assume that the pipeline is one region. Make sure you're breaking it up into regions and you're justifying the type of tools that you're going to use. And this also ensures that the operator demonstrates that they know what's there. They know there's a casing there. They know there's a paved crossing in this area that they can't run a CIS across, so they're going to do something else. And then also make sure if you've got other applicable procedures when you're performing the work, exposed pipe, you're doing your dig, make sure you're filling out your forms, make sure you're following whatever other procedures are applicable. Just because you're in the middle of an ECDA doesn't give you carte blanche to default from whatever your existing procedures are. So make sure you're still cognizant of what else needs to be done while you're doing this work. So to wrap up here, ECDA assessments, they can really give you some useful results if you do it right. They can give you some great data, a great picture of what your pipeline looks like from an external corrosion point of view. Again, each of the 4 phases has a specific purpose and will tie in with the other phases. Don't skip them. And then documentation. Documentation is always, always, always an issue for operators. This is a large data pull to do a project like this, but it is imperative that you're documenting everything. You're maintaining your documentation. It's good for you as an operator because it gives you data to use when you're doing your integrity assessments, you're making decisions about what you're going to dig, what you're going to repair, and then it also demonstrates that you're in compliance with the regulations when you're going to be audited, because you will be audited. So that's it for me. I'd be happy to open it up to any questions.
All right, we do have a couple questions here. You ready?
Go ahead.
If you find corrosion at a dig, are more digs required?
Not necessarily. If you find the corrosion at a dig, which ideally you should be finding corrosion, the data is driving you that way. You don't necessarily have to do more digs. However, what you do need to do again is you need to look at your data criteria and you need to evaluate the severity of the corrosion that's being found. If you find that the corrosion is more severe than anticipated, you should reprioritize your indications, which may then lead you to another dig, but you're not necessarily required to do another dig just because you found corrosion. Again, the process takes you where you need to go.
Okay, and then it says, what kind of field examination results could lead to the DA process becoming, sorry, it's hard to read this, becoming infeasible?
So if you've got field work that you're getting indications that are not aligned with each other within a reasonable space. I mean, we're talking about you're performing a CIS at 5-foot intervals. Everybody's got different pace steps. But if you're not getting consistent data, if you're getting an indication here, but then you're getting another indication 5 feet away or 15 feet away, nothing's aligning, you may want to consider redoing some of your field work. In general, everything should be aligned. There should be, you should be using station numbering and GPS coordinates to validate where your indications are. But in general, if you're getting data back that nothing seems to be aligning, nothing seems to be working, you may want to reconsider, or you may want to consider doing the survey over again. I hope that helped.
Okie dokie. Well, we'll wrap it up right there. We hope you all enjoyed the presentation today. I'll be sending out a copy of the presentation as well as a link to the recording later on this afternoon. So go ahead and be out on the lookout for that. And thank you for joining. We'll see you next time.